Now I'm going to look at, well, carrying out basic pre-processing of the data we have read in using Pandas. And frankly, this is something you should be familiar with because, as I mentioned in the course outline and all, it would be useful for the students to have some kind of Python data science experience. But in case you do not have any Python data science experience, I'm just going to briefly run you through some common Python pre-processing techniques and methods which you are likely to encounter when you work with your own data. And with this lecture, you should be by now you should be able to read in CSV files, Excel files using Pandas, and with this lecture you'll be able to carry out the basic pre-processing you need before you carry out any kind of machine learning or data science analyses. So you can import Pandas as PD, NumPy as NP. I'm going to work with this file called titanic_raw.csv. I'm going to call the function pd.read_csv as before, and I'm going to store the data in the variable Titanic. Now we can look at the data, titanic.head. And you can see the first 7 rows because, well, the first 8 rows, 0 to 7. And indeed, we can even say Titanic.tail, which will just show us the end of the data. So basically, these are the last couple of rows of these data, which we get from tail. And you can see we have passenger ID, survived, P class, name, sex, age, patch, ticket, and so on. Now we can see the different data types. So Titanic.dtypes, see the data types, and we can see something like passenger ID is an integer data type, age is float, cabin is object, and so on. We can remove the columns that we don't want. So I don't want passenger ID. So for that, I retain the variable Titanic.drop. So in Pandas, the function .drop allows us to drop the columns, and I specify the columns that I want to drop: passenger ID, name, ticket, and indeed you can specify any other column name. And access is equal to 1 means that it is essentially the columns that we want to drop. And now when you look at the data, this is what we are left with: survived, passenger class, sex, and so on. Now, the other challenge that we face when working with real life data is that we tend to have NA. So something like NaN means NA, which means that no data values are available for this particular row, for this particular row, for this particular row, and so on. So in this scenario, carrying out any analyses becomes difficult and errors get thrown up. So now the first thing we should see is, do we have NAs? I'm going to say print columns with null values, and they're going to be listed one after the other. So Titanic, so basically this is my data frame which stores my data. Titanic is null, so it's going to see if a column has null values, and .sum is actually going to sum up the total null values. So like so. So the column age, it has 177 null values, 687 null values for cabin, and embarked has 2 null values. We can even compute the percentage of missing data by saying Titanic is null.sum length of Titanic. And this means that in age, well, 19.8% of the rows have null values, and in cabin, 77% of the data, they have null values. Now we are going to make a copy of the data frame by saying and I'm going to store the copies in variables T1 and T2. Titanic.copy deep is equal to true, which will make an actual, like a complete copy of these data. We can drop all NAs. So I create a variable T_drop. T1.drop NA, that's going to drop all the columns. It is going to drop all the rows which have NA values. But obviously in this case, the rows will be dropped for all the other columns. So, we'll end up losing 77% of our data. So anyway, in this case, we do get columns with null values because no null values are left. But again, we could very easily end up with very little data. So, and now once we drop the NAs, we can compute basic summary statistics. So on our data, or at least on the quantitative data. Now we can just decide to drop columns, say, where more than 50% of the rows have missing data. And for that, I have cabin, so T2 head. And indeed, I can drop just the cabin by saying T2.drop, again drop, cabin in place true access 1. And that's because this one has 77% of the data with missing rows. Now I'm going to create another copy by saying dot copy and store the results in variable t3.head. And I'm going to print all the columns with null values. T3 is null sum. So basically, it's the original data frame of Titanic that we are working with. And now if you don't want to carry out something like removing the rows with NA values, because you may end up losing a lot of data, as we did in the first case, we can carry out basic data imputation, which means we are going to replace which means that we are actually going to replace the NAs. So now the first example is age. Age is a quantitative variable. We can replace the missing age values with average age values. So I create a variable t3 underscore imp underscore mean, t3 age, because this is the column I'm interested in, dot fill NA. So now we are going to use the function fill NA instead of drop NA, t3 age mean. So now basically all the missing rows in the column age, they'll be replaced by the average age values. And indeed, we can even use median. We can even use median values. So I'm just going to say T3. Fill NA. Age, because that's the column I'm interested in, dot median. And obviously the empty round brackets. And as you can see now, I don't have any NAs because, well, the entire column has been printed out, but these have been replaced by the median age values. So basically what this does is it fills NAs of age with median age values. Now the other column that we had, which was full of NA values, was the cabin column. And cabin, we can run this, and essentially we are going to have null values. And anyway, I can still run it. So anyway, we have where we can count we have cabin with NA values, and cabin values were qualitative. So in order to carry out data imputation here, we can count the qualitative variable. So T3 cabin dot value counts, and it's actually going to count how many have which column categories have what quantity. Now we can compute the mode, and mode means we'll identify the most common value, cabin underscore mode. I create this variable cabin underscore mode, t3.valueCounts.index0, and this tells me that G6 is the most common value. So now I'm going to fill the missing values with mode, which is the most common cabin value. So T3 cabin.fillNA cabin underscore mode in place true. So all the NAs will be replaced by G6. And now we have age 177 because that's a new data set. But anyway, at cabin we have 0 missing values because all missing values have been replaced by G6. And basically these are some of the most common data pre-processing tasks you have to undertake with most data sets before we move on to more advanced topics relating to actually doing something with the data.